Variables and values. All applications use data from different sources, such as user interfaces, databases, network services, or other sources. Variables are the way to go when storing values. Operators and expressions are used to manipulate those values. Data types. Variables are declared of specific data types, and because C# is a type-safe language, the compiler guarantees that the value stored in the variable is of the correct type. This table shows the most commonly used data types. Expressions. An expression is made up of operands and operators. You use expressions to evaluate or manipulate data. All expressions evaluate to one value when the application runs. The result will depend on the data type and the operators that are used. Operand. An operand is a value. It can be a number, a string, or of any other type. Operands can be constants, literals, variables, properties, or function returns. Operators. Operators define operations on operands. There are operators for the basic mathematical operations such as additions, multiplications, and subtractions. There are a number of operators in C# that fall into the following categories. Unary. This type of operator is used to convert the value of a single operand, and you can place the operator before the operand. One example is when you change a positive value to a negative value with a minus sign. You could change the positive value 1 to a negative 1 by placing the operator in front of the 1. This would be the same as multiplying the value by -1. Binary. This type of operator is placed between two operands. Commonly used operations of this type is multiplying or adding values. Ternary. There is only one ternary operator in C#, question colon. You can use this operator in conditional expressions instead of using the traditional if-then construct. For example, value equals true, question mark 10, colon 100. This means that if the value is true, 10 is returned, otherwise 100 is returned. One important rule regarding expressions is that the type of the expression is the same as the type of the operands. This means that some operands might need to be converted to ensure compatibility. If you, for instance, divide two int values, you might expect the same result as when dividing a double with an int, but that is not the case. For example, dividing 5 by 2 equals 2, not 2.5. And if you divide 5.0 with 2, it equals 2.5. The following table shows the operators available in C#. There are classes in the .NET framework that contains methods that you can use when performing mathematical and string operations. One of those classes is system.math. Using variables. Before you can use a variable, you must declare it and give it an identifier. The identifier is the name you access the variable with. When you declare a variable, it will take up a small portion of memory to store the value associated with it. You can declare multiple variables on the same line, separating them with commas. All variables declared this way will have the same data type. In C#, you must assign a variable before using it. C# has implemented this way to avoid using variables with random values. This was a source of problems in C and C++. Implicitly declaring variables. A great way to declare variables is to declare them implicitly. Instead of explicitly stating the variable type, such as int, double, or string, you can use the var keyword. The var keyword uses the assigned value to determine the data type. Once a value has been assigned, the data type can no longer change. In many cases, the code will be cleaner and easier to read when using the var keyword. Object variables. When creating a variable from a class, it is undefined before the new operator is used to create an object instance. The instance is placed on the heap, a memory area designed for objects. The new operator does two things. First, it causes the CLR to allocate memory for the object on the heap, and then it invokes the constructor in the object to initialize its fields. A class can contain multiple overloaded constructors. Which is used is determined by the parameters you specify when using the new operator. Accessing type members. After an instance has been created by the new operator, you can use the variable to access the content of that object by using a period after the variable name. When accessing a method, put a parenthesis after the method name. If the method takes parameters, then pass them into the method in the parentheses. When accessing a property, you use the property name. You can set the value if the property has a set block and get the value if it has a get block. When declaring a variable, it will take up a piece of memory when the application is running. Where in the memory it ends up is determined by the data type. Value type variables such as int and double will end up on the stack. The stack is a fast memory storage where the values can be removed as soon as the variable goes out of scope, when it no longer is used. Object variables, on the other hand, will end up on the heap that handles large variables. When an object variable goes out of scope, the object will undergo a cleanup process through the garbage collector, GC, which is slower than the stack. Variable naming rules. There are certain rules for naming variables that you must adhere to. Rule 1. An identifier can only contain letters, digits, and underscore characters. Rule 2. An identifier must start with a letter or an underscore character. Rule 3. The identifier cannot be the same as a reserved C# keyword. C# is case sensitive, which means that you potentially could use the same variable name, only changing the casing. One instance where you might consider using this to your advantage is when naming a property that stores a value in a variable. When naming variables, you should follow a naming convention. Use one convention and stick to it.